Let's consider LHopital's rule for the indeterminate form 0 over 0. Suppose that f and g are differentiable functions on the open interval a to b. And let's suppose that this interval contains some x equals c value. And also suppose that g prime of x does not equal 0 for any x value in that interval except perhaps x equals c. If the limit as x goes to c of f of x over g of x yields the indeterminate form. In other words, if the limit as x goes to c of f of x equals 0 and the limit as x goes to c of g of x equals 0, if that happens, then this equality holds. The limit as x goes to c of f of x over g of x is equal to the limit as x goes to c of f prime of x over g prime of x. And that's provided, of course, that this limit does exist or is infinite. So let's suppose that the conditions are met. Let's suppose that we do have the indeterminate form. The limit as x goes to c of f of x over g of x does give us the indeterminate form of 0 over 0. And let's suppose that the limit exists. The limit as x goes to c of f prime of x over g prime of x does equal L. Now, what I want to do is define two functions, capital F of x, which I'll just define it this way. I'll say capital F of x equals f of x, provided that x does not equal c. But if x equals c, then capital F of x just equals 0. So capital F of c equals 0. I define capital G of x the same way. Capital G of x equals g of x, lowercase g of x, as long as x does not equal c. But if x does equal c, then capital G of c equals 0. Now, from this, we see that the capital F of x and the capital G of x are both continuous on this interval, c to x, this closed interval, and differentiable on the open interval, c to x. Now, I put the c first and then the x. I could have done it the other way. It doesn't matter. But here's the thing. By Cochise formula, we have that capital F prime of z over capital G prime of z is equal to capital F of x minus capital F of c over capital G of x minus capital G of c for some z between c and x. So this is Cochise formula. Now, remember that capital F of x equals f of x, provided that x does not equal c. Capital G of x equals g of x, provided that x does not equal c. And also remember that capital F of c equals capital G of c, and they both equal 0. So here's what we have. We have that f prime of z, capital F prime of z, over capital G prime of z is really just equal to capital F of x over capital G of x, which that's just f of x over g of x. So here's what we have. We have f prime of z over g prime of z. All I did was I just substituted in here. Instead of capital F prime of z, I just put f prime of z. And instead of capital G prime of z, I put g prime of z because of the way the functions are defined. That just equals f of x over g of x. So here's what we have. We start off using Cochise formula, and because of the way we define capital F and capital G, it just simplified down to this. Now here's the thing. Notice that if I work with this, f of x over g of x, and I let x go to c, that's exactly the same as if I let z go to c over here. So the limit as x goes to c of f of x over g of x is definitely equal to the limit as z goes to c of f prime of z over g prime of z. And we've already said that that equals L. So here, this is what we wanted to show.